Nothing ignites the human imagination quite like making contact with aliens. But even as we continue to dream up extraterrestrial civilizations in science fiction, researchers at the SETI Institute are on a real-life hunt for alien megastructures, light signals, and other signs of intelligent life in the universe. I'm really excited to welcome Anne-Marie Coady. She is a research scientist at NASA Ames as well as at the SETI Institute. Thanks so much for speaking to us today, Anne-Marie.
Thank you.
So I want to just start with kind of this popular image of SETI, which I think, people of my generation would think of Jodie Foster with like literally the headphones on, listening to an alien signal coming in. Mm-hmm. How close is that to what the research is actually like? And what's the more day-to-day experience of being part of SETI?
Well, SETI is Search for Extraterrestrial Intelligence. So people who are essentially looking for intelligent life elsewhere in the universe. And certainly there are people who do that. But there are also astronomers who are researching in other areas, exoplanets, solar system objects, planetary scientists, even people who do Earth-based geology type projects. But if you look at just those people at the SETI Institute who are trying to find intelligence elsewhere, that again kind of falls into a range of activities. It could encompass astronomers who are identifying exoplanets orbiting around other stars and who are looking for just molecular signs of life. They're not even using those radio telescope dishes that you may be familiar with. What I do, which is actually a different area, looking for what we call technosignatures. And that's not looking for like molecular based life. It's looking for very advanced civilizations. And we're actually doing that with optical telescopes.
So how does the SETI Institute look for life? What does that sort of search look like?
They have the Allen Telescope Array, and then there are various projects which some SETI scientists are involved in, which essentially share time on larger radio telescope dishes. For example, there's something called the Green Bank Telescope in West Virginia. And so there are other telescopes around the world that are doing some astrophysical research, and then in between they're doing some SETI searches. And then we have people who do sort of a lot of more philosophical thinking about just the possibilities of what could be out there. When you watch the movies and you see depictions of aliens, they're kind of like people, but with distorted facial features and whatnot. Mm-hmm. And in some sense, that's kind of like expected because we don't have much imagination as human beings. We think anything might look like us. But what about like artificial intelligence, building powerful computer systems that can then just run everything? Maybe we should be looking for something like that. That's just like, numbers, computations, machines that are out there doing things. And then there are folks like myself who are doing what could be classified as optical SETI. And one example is if somebody had on another planet had a really powerful laser and they beamed it in our direction and then kind of blinked it on and off, that would be a very unique signal. And for microseconds or so, it could actually overpower the light of the host star on those timescales, because the host stars don't blink on, sub-second timescales, at least not that powerfully. So you kind of filter out, you've got a planet that you can't see, you got a star, but you could, if you do something quick enough and powerful enough, you might see that. And then I'm also working in the optical wavelength regime, looking for something completely different, which would be what we call alien megastructures for short. Essentially, any artificial structure built by an intelligent civilization, perhaps for energy harvesting purposes. If something is in orbit around the host star and doesn't completely cover it up.
So you're looking both for sort of signal that would be flashed in the optical wavelength and then the blocking in the optical wavelength. That's really amazing. What kind of observatories and tools do you use to look for these types of possible signals?
For me, I'm just looking for the light blocking. And it turns out this is sort of easily done because there are other things that are natural objects that block stars, including planets and other stars. And of course, there are space telescopes, including NASA's Transiting Exoplanet Survey Satellite, known as TESS, and its sort of predecessor, Kepler. They operate exactly on this principle. We look at thousands, even millions of stars, take image after image, and then we translate those images into a sequence of each star's brightness versus time. So both eclipses by other stars and transits by planets have a particular signature in the light curve. Whereas if you had an artificial megastructure, you could potentially cause a different signature that would be unique and potentially also much deeper. And we now have, for our project, upwards of 50 million stars observed by the TESS satellite.
That, I mean, when you say 50 million, yeah, that is a truly large haystack, a cosmic haystack to be looking through. You mentioned you have some of these tools. Is that like artificial intelligence?
So we're essentially using machine learning technology, and the area of machine learning is called anomaly detection. And it's actually very similar to the technology that your bank or credit card company might use to find fraud. It's essentially looking at the sequence of something over time, whether it be the star's brightness or your credit card purchases, and it's looking for something odd that doesn't belong there.
Have you found anything yet that doesn't have a clear explanation, or as most things have an astrophysical origin of some kind?
I will admit we don't entirely know what we're looking for. It's kind of like, you know, as I mentioned, the TV images of aliens. What do aliens really look like? We don't know. So like, what kind of structures would they build?
Yeah, that's sort of the double-edged sword of having billions of star systems in our galaxy. That's great and exciting, but yes, takes some time to actually sift through them all.
My team has a student from the University of California, Berkeley, who's running software to simulate, like, what if you put some shapes in orbit around a star? What if you put a series of giant triangles? How would we see that from Earth? So there's no one signal that we're looking for. And so we do have to be careful to not rule out things that if we don't understand them. But for the most part, we are looking for stars where they have relatively constant brightness, and then there's a dip in that brightness kind of intermittently or periodically. And so the more sort of weird undulating patterns, as an astronomer, I might not immediately recognize what is causing that, but I bet if I looked further into it, it probably has an astrophysical explanation.
I understand you're an artist yourself. There's certainly enough in terms of worlds and cool space art to do, and that's really fun. Do you find that kind of helps when your scientific goals at all?
People talk about how, science and art, some people think of them as very separate, but both of them require harnessing your creative power to kind of explore what's out there. And so there's actually something kind of fundamental and common. And I like using the art to, get that side of my brain going, get the juices flowing, and try to just think outside of the box. I think it's very helpful. And, more scientists should probably recognize the value of art.
For sure. And I think too, even just when we write articles or things like that, or we use NASA footage to have these artist conceptions of these worlds, like some of the ones that you do, that's so important for people who, maybe haven't thought about what a binary star system looks like or things of that nature, right? So I think it's huge for engaging people as well. And, on that note, like, why do you think humans are a lot of the time predisposed to assuming that we're not alone?
Well, if you look back at the history of astronomy, originally we thought we were the center of everything. We didn't even think, the sun's in the middle of the solar system. We're like, no, we're in the middle. Everything orbits around us. And so there's this sort of trend throughout history of this gradual realization that we're not the middle. And now we're probably not the smartest. We look at our sort of one of the fathers of SETI, if you will, Frank Drake, came up with the Drake equation, which is sort of a way to estimate the possibility of intelligent life out there. And it depends on the number of habitable planets, which we now know is probably pretty high. It also depends on other factors that we don't know how to constrain, like how long does an intelligent civilization actually last? Because we humans haven't been around for very long, and we are struggling with things like sending carbon dioxide into our greenhouse gases, into our atmosphere, and causing climate change. And, that could be the end of us relatively soon after the emergence of human beings.
To that point, like if there were to be a really compelling, unambiguous megastructure signal, say, what would be the kind of steps that NASA or SETI would take to inform the public about that?
I think for a while we would just be quietly going about our scientific research, getting all the backup data possible. I mean, this already happened to some extent when there was a discovery of a star that it's now known as Boyajian star, which was observed with the Kepler telescope, and some citizen scientists who were actually involved in looking for planets in that data set just noticed that the star had kind of bizarre and deep fading events. So the astronomers said, oh, this Boyajian star, this is kind of strange. Could this be the megastructures? And that's sort of this motivation for our current search. Initially, nobody knew what it was, but they were very diligent, and Tabitha Boyajian, who's the star was named after, got time on other telescopes from the ground that looked at different wavelengths than what the Kepler telescope was observing at. And it turns out that there are different structures that can be in orbit around stars. An opaque megastructure, which was kind of what we'd expect from a civilization, would cause the same amount of fading in the light curve, regardless of the wavelength. Whereas if you have just a lot of dust, which is something that's kind of common out in space, blocking the starlight, you would expect the fading event to be more extreme at red wavelengths. It's similar to like when the sun sets and the sunlight is coming through dust and other particles in our atmosphere, and the sun appears to be more red than blue at that point. Something's really a smoking gun, like we get a signal and it says hello earthlings or something, right? Or someone's put a structure in orbit around the star that says hi there, what we would actually do. And I'm not sure what the answer to that is. I would have to have some big conversations.
Yeah, it's an eventuality that's so mind-boggling.
We don't want science to be happening behind closed doors. We want the public to see it's a process. It's not just like you discover something instantly and there it is. You've got to follow up and test all hypotheses.
There's a division sort of between the astronomical SETI search and then a lot of the stuff that people talk about with UFOs and things like that.
I think it's hard for astronomers because we're looking at everything beyond Earth. The fact is, when we don't have enough data, we just have a report of I saw something. There's so many possibilities that, professionally, I would have no capability to evaluate. But personally, I don't believe any of that is aliens. It just seems strange that things would zing around in our atmosphere but never actually interact with us.
For sure. And I wonder if you could just zoom out on the ultimate question, like say we do learn that we are not alone, even if it's just like we find past life on Mars, just some idea that, okay, Earth life is not unique. What would that mean in terms of like the paradigm shift, you think, for our culture and society?
I think if we had a global reminder of our own fragility and that, we need to kind of do a better job at just like surviving as our own civilization. So, if you see, there used to be life on Mars, but it's gone, that's one reminder. Or likewise, if we detect life elsewhere and find out we're not the only ones, that both of those cause people's sort of minds to expand, like, wait a minute, like are all the things that I'm thinking about and worrying about actually kind of trivial? Because sometimes I think they are. We need to think about what are the big issues. We need to take care of our planet, and do we have examples of beings out there who didn't do that and unfortunately suffered a terrible fate or something? It would be kind of interesting to see how humanity reacts.